Hello and welcome to my channel. Today we are going to discuss how to write functions in R and basics of function arguments, how to return a value from a function, and very important scoping rules in R. Next, we will discuss control structures, how we can use if-else to control program flow, switch to check multiple statements, and run checks on entire vectors. Next, we will discuss loops and are they really required, and some control loops like break next. R has two types of functions. One is R built-in functions like you have sort, mean, read CSV, and many more. Next, we have user-defined, or you may call it custom functions. In this video, we are going to talk about user-defined functions. If you're new to the programming world, a function is a set of statements organized together to perform a specific task. Here is a simple function example. I named the function hello here. A function is an R object, so it can be named like any other R object. To write a function, we use the keyword function and assign it to some object. In this case, hello. We mostly use curly brackets in order to contain multiple statements. However, if there is only one line of code inside the function, we can choose not to use the brackets. I have provided both the examples here. Example 1 with the curly brackets, example 2 without the curly brackets. This is the body of the function wherein I am printing hello programmers. Let's run it. So the whole function gets printed out on the console here. So you can call it using the hello, which is the function name, followed by round brackets. So the hello programmers got printed as expected. The example 2 without the curly brackets is just to show if there is only one line of code, you can write a function without curly brackets as well. Let's run it. Hello, no curly brackets got printed as expected. A function argument is how you get information into the function, and you can define as many arguments you need to make the function work. In this example 3, this basic function hello.1 takes only one argument called as name. In this case, argument name is name here. Again, it can be anything XYZ as per your liking. And in the function body, I am printing hello name. This argument name determines what name gets printed with hello. So let's run the function first. So the function got printed into the console. Now we need to call hello.1. As you can see, in hello.1, one argument is required. So while calling hello.1, I mention John. Let's run it. So John gets assigned to name and it further got printed as hello John. Example 4 shows a function hello.to that takes two arguments, name 1 and name 2. Here it prints hello, then value of name 1 argument, and then value of name 2 argument. Let's run the function. Now there are many ways to call the function and pass the argument. Like in line 37, we have specified the argument while calling the function. Say name 1 equals to John and name 2 equals to Sarah. Let's run this. Hello, John and Sarah got printed. So line 38 shows if we are specifying the argument like this, order does not matter. So I have first mentioned name 2 Sarah and then name 1 John. It automatically gets assigned as hello John and Sarah. Line 39 shows order matters. I have not mentioned the argument name, name 1 and name 2 here. So it is taking the arguments positionally. It assumes the first argument goes with name 1 here and the second argument Sarah goes with name 2 here. Let's run it. Again, hello John and Sarah. As mentioned earlier, you can define as many arguments you need to make the function work. We have seen two here. So as function becomes more complex, you might need more. You can choose not to specify the arguments every time and can go ahead and use default arguments. Like in example 5, hello.def, name 2 is already assigned to Sam, which is a default value. This is helpful if you don't have a value for name 2 and R will use the default value Sam. Let's run it. So line 46 here works as it did before. Hello John and Sarah. The value you pass will override the default value. So the line 47, it did not have the name 2 is not provided. So it takes the default value. So hello John and Sam got printed. Line 48, that's line 48 gives name 2 equal to Sarah and there is no name 1. So this will not work because we specified the default value for name 2 and not name 1. Line 50, as you have seen the function hello, def takes two arguments. So name 1 and name 2. What if we call function using three arguments? Let's run it. We get error because there is no room for the third argument. Now you have seen it is very important to use the correct number of arguments and correct name of arguments. One way to get around this is to use the dot 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 argument. It is very tricky but very powerful if we use correctly. One simple basic example of dot 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 is example 6 hello dot d. Let's run it. So here I mentioned name 1, name 2 and dot dot dot. So the dot 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 will catch any extra things we put there. So let's call it hello dot d, John, Sarah and Jerry. So John and Sarah got printed. Jerry will be completely ignored here. So the conclusion is if you give three arguments to a function that require two arguments, so the dot 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 will catch it. So the most common reason why functions are used as it returns some sort of value. We feed some input, function operates it somehow and returns a value. In this example 7, the function addition is created which will add the provided arguments. So this function will input x and y and return x plus y. Let's run it. And I am passing 2 plus 4. So please notice I am not providing any command to print the x plus y output. By default, R will return the last line of code. So we need not to specify what to return. In line 68, I am passing x as 2 and y as 1 to 5. It returns the output as expected. At times, you don't want the last line of code to be returned. You can explicitly define what should be returned. Say in example 8, x plus y and x multiplied by y is there. So both will be executed, but only x multiplied by y will be returned. Let's run it first. So it will return 8. So I can choose to return x plus y by saying return x plus y. Let's run again. So here. So it shows that anything that comes after the return statement does not get executed. So x multiplied by y will not get executed here. Therefore, the solution is for the cases where you want more than one value from a function, we need to combine them into a single object. Say in example 9 here, I have assigned value of x plus y to plus variable and x multiplied by y to multiply variable. So further this statement in line 84, it will return a single object, a list containing the two values. Let's run it. So both will be returned. But For cases like this, we should name the elements so we can easily refer the values later. So in this case, I can name it as PL say and multiply as MUL. So yeah, it will give you PL as 6 and MUL as 8. You can choose to rename it. So like this function can return a number, a vector, a string, a data frame, or a list like this. If I assign any value to j and give a command to print it, I will print it. Another example 10, if I create a function rules and I have created a new object k inside that function and then call this function, R will print the value of k as 6. So, but if I want to print the value of k outside the function by just printing k, it will give me an error. Why? This is because of the way scoping works in R. Scoping refers to the way R searches for values when we call them by name. I'll explain this with another example. If I create an object M outside of the function and call it inside of the function here, print M. So what R does it will look uh, first for the value of M locally. That means inside its function. If it couldn't find it, it will look for it one level up, either the parent function of which our function is the part of, or in this case, the global environment. That's called scope 2. 4 is printed, which is globally available. So if the M is also defined locally, I'll again run it and again call it. It will print whatever was there in the local environment. So to answer my previous question in example 6, that why can't we call k outside the function? So if the new object is created inside a function, R will only find it if it is called inside that particular function. We can use if-else statements in order to control the flow of information. If you are new to the programming world, if-else statement is a very common structure where code is executed based on certain decisions. Like here is the pseudocode that says if this is true, do this, else do this instead. When I say this is true, must resolve to a logical value. We use curly braces to contain a body of code. Let's move to examples for understanding. Here I have assigned value 1 to the variable x. So the condition is if x equal to 1, it will print hello. Let's run it. It prints hello. So this part before executing, it will check whether x is equal to 1. If yes, it will print hello like here. If not, nothing will happen. Please note, understanding if statements and how they can really structure flow your program is very important. Sometimes a simple if statement won't suffice. Perhaps action must be taken if the if statement fails. So that's why we use else statement here. So in example 2, the first line x greater than 1, it checks whether x is greater than 1 or not, which it is not. So the if statement fails here and goes to the next condition, in this case else. Let's run it. So it prints no hello. There are some of the relational and logical operators mentioned here, which you can use while checking certain if-else conditions. At times, using nested if-else statement for multiple conditions could get complex. So we have switch statement, which is one check against many possible results. So function switching in example 5 shows how you can use the switch command. Inside the function switching, you can call switch. So the first argument is what you will be testing. In this case, x. Next, we have key value pairs argument. Say if x is equals to a, it will return first. Similarly, if x is xy, it will return line. Similarly, like this, you can add as many key value pair as you want. Say if I pass data, it will return signs. Then we have other, which is the default value. In case none of the above is true, other is returned. Let's test our function. So here I am passing a. That means the value a will be assigned to x, and further the value of a is first. So it should return first here. Switching to will return guitar. So see here, what if I pass something which is not there? Let's check. It will return other. So this is how the switch function works. Being that R is a vectorized language, we have special statement called IfElse statement. The IfElse statement is sort of like single function. It is computationally better when checking vectors. For example, we have a vector x in example 6 and we need to check some conditions on this vector. So we will write if else. So this will take three arguments. So the first is what you are checking. Basically the condition. I am checking if in this vector, if we have x equals to 1. Second is what to do if the check is true. Third is what to do if it is false. Let's run it. So the each element here in the vector x will be checked for x equals to 1 and we got the output as series of yes and no. So if the corresponding value is equal to 1, yes is returned, and if not, no is returned. So the if else statement is a great way to check a vector element by element and allow a lot of power and control. So let's see example 7. X is the same as before. So there is another vector y. In this case, both x and y needs to be 1. So I'm checking the condition is x equals to 1 and y is also equals to 1. So if this condition is true, yes is printed, else no. So it will check 1, 2, 2, 3, 1, 1. So the third index will provide 1, 1 as true. Let's run it. So here the third index will give you true. So we got the output as expected. Now the question arises, do you really need loops in R? Loops can slow down your program. R offers many other alternatives that pays off in terms of efficiency. But yes, again, there can be times when it is required to use loops. So yeah, it is good to know them. Let's see a simple example one. The for loop requires a iterator. So first I is iteratively set to each value in sequence 1 to 4 and then body of the loop which is in curly braces is executed one by one. Let's run it. So 1 to 4 got executed. Say a vector v. I'll run it. And I want to print or operate on the value of v step by step. So for that, say I want to print it first. In this case, I know the length of the vector is 4. So 1 to 4 works. In cases where you do not know, you can choose to run the program till length of that particular vector using length vector. So let's run it. So the values got printed at each iteration of the loop. So I hope you got an idea here on how the for loop works. In example 2, I am using the air quality data set. Let's see how it looks like by printing few rows, say head of air quality. So the air quality data set consists of ozone, solar.r, wind, temperature, month, day, and there are many months basically. So how we can evaluate the mean of these ozone values for every month using for loop? Let's check out an example 2. So for that, I have used for M. M is my iterator in unique air quality dollar month. So this will give you all the unique months. Let's run it alone. So yeah, these are the months in the data set. So in this example, M here is iterating over unique values of month 5, 6, 7, 8, 9, as you can see here. So let's see the body of the function. So here, ozone for M, air quality dollar ozone, we are fetching the ozone values from the air quality data set for every month. So the ozone values for each month will get stored to this variable ozone for M in every iteration and will be replaced in next iteration for next month. Next step here, mean is evaluated for that month and stored in the result variable here, and then using the cat here, the result will be printed. So the cat will concatenate the statement mean per month, and for that particular month M will be present over here, is then the result will be uh, printed. Let's run it. So here mean for every month is evaluated. So yeah, this example of for loop can easily be done by group by and summarize function from the dplyr package. You can check out the link here. But the idea is same on how to iterate over a data frame and apply some sort of operations on every element, or could be a vector or could be a list. When working with loops, we do not know how many iterations we need. For those cases, while loop comes into picture. Here's the structure for the while loop. It begins by testing a condition. If it is true, the body gets executed, and then again the condition is tested, and so forth until the condition is false, after which the loop exits. So let's discuss it with one example. So here I have assigned value 1 to x. Let's run it. And I'm providing a logical condition for the loop to run till x is less than equal to 4. So here the catch is, if I print it like this, it will keep on iterating with x equal to 1 and not stop. Therefore, we need to increment the value of x. Here I am choosing to increment by 1. You can choose 2, 3, 4 as per your liking. So if I run this, x is printed till x is less than or equal to 4. So the condition mentioned here can be anything. Again, remember, if you do not have a good checking statement, you could get into infinite loop and crash your program. Make sure you are checking for something that is appropriate. I agree it's a very least popular loop, but yet it comes in handy with every now and then. Say you have iterations for 1 to 10 and you don't want the fifth iteration, or you want to exit the loop after few iterations. For that, we have next and break. In example 4, the for loop iterates in sequence from 1 to 10. Within the loop, I have given a condition: if the value of I is equal to 5, or using a pipe operator is equal to 8, that particular iteration will be skipped using next. We can check the next command is working or not by printing the value of I and run it. Here, as you can see, the fifth and the eighth iteration is being skipped. In example 5, break is used to exit the loop. See here, in the iteration 1 to 10, I am keeping the condition that if the iteration reaches 4, break the loop. That's fine. So here it only prints from 1 to 4. So this is all about functions, control structures and loops. Please don't forget to like, comment and subscribe. Thank you.